Alright, you are welcome back to Introductory Mathematical Analysis B. Okay, we are still in 20.7, which deals with fundamental theorem of calculus. Theorem of calculus, where we use the definite integral, or we are dealing with the definite integral. Okay, so I quickly go over some properties of the definite integral. Properties of the definite integral. Some properties of the definite integral. Okay, so number one of that property is that if A is greater than B, okay, A is greater than B, then if A is greater than B, then the integral of AB of f of x dx will be giving us minus dA f of x dx. Okay, all right, so if we have A greater than B, then if we have the limit to be A to B and we change the limit, what we are just saying basically is that when the limit changes, then the negative will come in front of the one that changes. Okay, so example, we will say from 1 to 2 of x squared minus x dx. Okay, I want to find this. I can find this in another way by changing the limit, but then there will be negative coming. So I can find this from 2 to 1, but there will now be a multiplication of negative. Okay, so instead of 1 to 2, I can swap the limit to 2 to 1, but there will now be a multiplication of negative. Okay, please take note of that. Then number 2, integral from A to A. That means if we are integrating from the same point A to A, then that will be 0. That will be 0. Integral from A to A is 0. Example, integration of 2 to 2 of x squared minus 1. You don't even need to evaluate this. This is 0 because the limit is from 2 to 2. They will cancel each other. They will cancel out and everything will be 0 because the same limit. Okay, the same limit of upper and the lower one. Okay, number 3, when we have integration of A to B of a constant multiplied by the function, then it's the same thing as pulling out the constant, then integrating the function. Okay, pulling out the constant and integrating the function. All right, number 4, if we're integrating from A to B of a function plus another function, of a function plus another function, is the same thing as integrating each of the functions separately and then adding them together. Integrating each of the function A, B separately and then adding them together. It's the same thing as integrating each of the functions separately and then adding them together. The same thing goes for subtraction. Okay. All right. Number 5. Integration of A to B of f of x dx is the same thing as integration of A to B of f of t dt. That means the variable is just the integration. The variable of integration is just a dummy variable. Whatever you integrate in t is also the same thing when you integrate it in x. Okay, so the function could change. I mean, the variable could change, but the integration stays the same. The result of the integration stays the same. So it's still the same thing as when you're integrating in u. So it's not every time we use x. We can use t, we can use u, we can even use z, we can use any variable. You can use any variable. You can use any variable. So the integration remains the same. Integration remains the same. Okay, all right. Number six property is that if we have a is less than or equals to a is less than b, a is less than b, but in between this a and b we have a c, so I put a c there. Is less than c is greater than a, but c is less than b. Okay, all right, let me do it alphabetically so that you can understand b then c. Okay, so if we have integration from a to c of a function, this is the same thing as integrating from a to b of that function, plus integrating from b to c of that function. Okay, so when we are integrating, for example, if we want to integrate a function from 2 to 10 of that function, I can break it and say I'm integrating from 2 to 6 of that function, and then I can add the remaining one from 6 to 10 of that function, and I will still get the same thing. Okay, that is what we are saying. Okay, all right, please take note of that. All right, now another one, number 7. Don't forget the integration of a to b. If I'm integrating the derivative, I'm going to be getting the function of it. So I'm integrating the derivative of this, so it will now become f of b minus f of a. This is exactly what we started with. Only that when we started, we said big F is the antiderivative. Of f of x, of small f of x. Okay, so what we now did is that we now said the integral of a to b of small f of x dx gives us the antiderivative, which is f of b minus f of a. Okay, but here again, the antiderivative of the derivative here is f. So f, small f of x is the antiderivative of the differentiation of the derivative of f. Okay, so the antiderivative f, small f without the bar, is the antiderivative of the small f with the prime, with the derivative. Okay, so when we integrate derivative, we get our f back. You know this before, please make sure that you understand. Okay, so take note of that property. Okay, let's quickly do this example to wrap this up. Okay, example. Evaluate 0, 1, 3, S3, S4 minus 1, s to the power 4 dx. Okay, so we want to evaluate this. Again, look at this, you will see that there's need for us to use substitution. That means to make something our u. Okay, what to make our u is this one. Okay, so let u equals to x4 minus 1. That's our u. So our du will now becomes what? 4x3 dx That is our u. Okay, but from here I can see x raised to power 3 can multiply it with the x, but not with 3, because this is 4. So I can rewrite this and say the u over 4 equals to x raised to power 3, the x, so that this can join with this here, and then we can call it the u over 4. Okay, all right. But now I'm changing the variable to u. I need to change the limit also. I need to change the limit. So here now, when x equals to what? The lower limit 0, then u will become what? 0, 0 minus 1, minus 1. When the upper limit is 1, so when x is 1, then u will become 1 raised to power 4, 1 minus 1, 0. So u is going from minus 1 to 0. Take note. All right. So now let's change the, so this will become, so what we have before as 0, 0, 1, I can put this 3, I can leave this 3 there, minus 1 raised to power 4, then I'm multiplying s3, the x, I'm rewriting it so that it can fit what I have here. So it becomes, I'm changing to u now, 3 u raised to power 4 multiplied by this becomes my du over 4. Okay, now I put the limit. The limit is no more 0, 1. The limit is now negative 1, 0. That is the limit now. That is the limit now. Please take note of that. Okay, from one of our properties, this is a constant 4. I can pull it out. This is a constant 3. I can pull it out. So it will be 3 over 4 out. Then minus negative 1, 0. This becomes u raised to power 4 du. Okay, that's what we have. Now, let's continue. So this is 3 over 4. This now becomes u raised to power 5 over 5. Then negative 1, 0. Okay. So what do? We need to now evaluate as 0 first, then minus, evaluate at negative 1. Okay, this becomes 3 over 4 is out. At 0, this will be 0 over 5. Minus, at negative 1 raised to power 5 all over 5. Okay. So what do? Now this is 0, 0 goes away. This is negative 1 over 5. So it will now be 3 over 4 multiplied by negative 1 over 4, and there's negative, so plus, multiplied by plus 1 over 5. Multiply, not, okay, please take note. Let me remove this so that it will not confuse you, but it becomes positive because this is negative out. This gives us negative, then it becomes positive. All right, so because it becomes not positive, the answer now becomes 3 over 20. So that is our, so what we're given to evaluate this is 3 over 20. So 0, 1, 3, S3, S4 minus 1, 4, the S is simply equals to 3 over 20. 3 over 20 is simply equals to 3 over 20. Okay, please take note of that. Please take note of that. All right, make sure you understand. Please ensure you understand.